they just doing additional maths? How boring it is.
Well, how about we do something fun? Surely that will have to do some action.
Okay.
So, have you ever heard of inhaling helium can cause a person's voice to change?
Yes, I've heard it before, right?
Well, before we start this experiment, we need balloons filled with helium and a pair of scissors. So, I feel obligated to tell you that inhaling helium is a fun activity, but it is dangerous as well. As you may know, our body needs oxygen supply to be able to function well. When we inhale helium into our lungs, we will cut off the oxygen supply from our body, thus it will cause some problem. When the oxygen supply is being cut off from our body, we will feel dizzy and it might even cause a person to pass out. When a person passes out while continuing to breathe helium, the person might even face death.
Death? But if we are careful enough, nothing bad will happen, right?
Well, that's true.
Okay, as your information, sound travels faster through a lighter gas than a heavier one. This is because the individual molecules have less mass and can move faster in the pressure changes of the sound wave, and the speed of helium is 3 times faster than in normal air, and this has changes the resonant frequencies of your throat.
So that the high frequency sound louder than the low ones.
Yes.
So we will do the experiment and we'll come back in later when we have our balloons. So we are back. So this is the helium balloon that we are talking about. So to do this experiment, we need a pair of scissors as well, as we need to cut open the balloon so we can suck the helium from it. So my partner Tiffany will do a demonstration. So Tiffany, please. Okay. So you need to pull the balloon and use the scissors to cut the opening of the balloon. Be careful when you are cutting so you do not cut the head. And doing this is extremely hard. So, Tiffany, go. Yes. Remember to hold the balloon tightly as the gas will escape.
Hello?
Well, do again.
Okay, I'll try.
From here we could see that the gas escaped, so that we will have no changes.
Hello? Yes, this is the change.
Well, oh wow, this sounds like a chipmunk, right?
Yes.
So as amazing the results are, inhaling too much helium is not so good for you.
And if you inhale too much of helium, you will not get the normal level of oxygen that you need for normal respiration. And this will cause asphyxiation, which also called as lack of oxygen within a few minutes.
So the lightheaded feeling that you are feeling signals that you need to take a break. So do remember that when inhaling, do not inhale helium from a high pressure stack, as it creates a high rate flow of gas. The high rate of flow will puncture our lungs and even send a concentration or mass of gas into your bloodstream. Then it will lodge into your brain. That might cause seizure, stroke, and even death.
Yeah. It's dangerous. I want to try it once.
Oh, try it again.
Hello? Yes, this is the sound. It's very strange.
Okay.
Why is this so painful?
This is called impulsive force. It might sound weird.
Impulsive force? What's that?
We have just learned this basic theory last month.
Oh, okay, I do remember right now. Impulsive force is the rate of momentum in collision or explosion.
Yeah.
Impulsive force is inversely proportional to time and the magnitude of force. If the time of impact increases, this will reduce the magnitude of force. If the time of the impact decreases, this will increase the magnitude of the force. Therefore, it produces a large magnitude of force, thus causing pain to my hand. If I hit the table with a slow motion, it has a different changes. So because the time of the impact is slow, therefore the magnitude of the time of impact is fast, so the magnitude of the force is small. Therefore, it will cause less pain.
Yes, yes. Now, wait, how can you memorize all this?
Because I am FFEA.
What is FFEA?
Fantastic, fabulous, extraordinary, and amazing.
Seriously?
So that's all for this experiment. We'll continue later.
Now we are back. Now we are going to do an experiment which entitled Musical Water. Dream, have you thought about producing music using vibrations?
Producing music from vibration. Is that even possible?
Yes, it's possible. We only need a few materials. Because water, a chopstick, and a phone. But this phone is optional. We only need this just to produce the video for us.
To be able to hit the beaker. So, can you do a demonstration of how this works? Well, is it beautiful?
Yeah.
I'm sure it is. Well, can I try to do it? Now, these speakers are used to produce, we want to use this speaker to produce a music. That is Shape of You by Ed Sheeran. Before we start to do this, we want to give a sample of the music for you to be able to listen on what we are doing. Well, is this song familiar? Well, we are going to produce the same song. But I'm hitting the beaker, my friend Tiffany will be singing. So, all we just need is to use 4 beakers. There is 175 ml, 200 ml, 225 ml, and 250 ml. These 4 beakers, you can just ignore them. So, the arrangement of the beaker must be good as we need to produce the same quality of the song like we just heard. So, yeah, like this. Like this. So, we'll be listening to the phone as we need to produce the same rhythm while my friend is singing. secret behind this?
As you know, each of the beakers produce different tone, or we can say pitch. The highest amount of water will produce the lowest pitch, and while the least amount of water will produce the highest pitch. This is because when we hit the glass, the small vibrations will produce sound waves which travel through the water, and the water dampens the vibration. Therefore, therefore it will favor the vibrations and the pitch will be lower, and the least amount of water, when we heat it, more vibrations will be made and the beaker will vibrate faster, and therefore higher pitch sound will be made.
So that is the experiment about musical water. Later, we'll be making an experiment about ice and salt. We'll be back later. Now we are back. So now we're going to do an experiment about salt and ice. So from this experiment, we need to see the difference between ice water with salt and ice water without salt. So we just need to prepare a few materials, that is thermometer, buckets of ice, salts, chopsticks for stirring, 2 beakers, canned drinks with ice in it. So now, Tiffany, can you explain me about the theory of salt?
As you may know, salt is an impurity which can lower the melting point of an ice. When salt is added into ice, it will lower the melting point. In other words, the ice will begin melting at below 0 degrees Celsius.
So, this concept is also used by many people from other countries. Mostly, those countries have winters and they have a lot of snow at the roads, snow and ice on the road. So, they needed to put salt to melt the ice quicker so they can walk freely on the road. So, the concept is the same as this. So, when salt is added into ice, the ice cube will absorb the heat energy from the surrounding. Thus, it will cause the temperature surrounding drop. This is due to the fact that the heat energy is being absorbed by the ice cube and the air surrounding it will lose heat energy. Therefore, the temperature of the surrounding will drop below 0 degrees Celsius. So now, we will start to do this experiment. One is without salt, one is with salt. So this is a packet of salt. But before we add salt, we need to find the initial temperature. Tiffany, go. So, Tiffany, what did you find?
They both are at 0 degrees Celsius.
Yeah. So now, I'm going to add salt into one of the beakers and stir it. So, what did you find?
It is very fast.
And it is now?
Negative 2 degrees Celsius.
Well, it proves that salt is an impurity that can lower the temperature of ice. So, if any one of you want to celebrate a certain event like Chinese New Year, Hari Raya, or Hari Diwali, you could freeze and cool down these candles by using this method. It is very fast and very useful as well. So in conclusion, salt can lower the temperature of ice cube below 0 degrees Celsius. So now, what do you do? Yes.
Wait. What's it before?
Ready? A toast of our celebration.
Yeah, we say.
So
refreshing.
Anyway, thanks for watching.